Okay. Good morning. So we were seeing a distribution system. Can anybody tell what we have already discussed yet? In yesterday class, what we have seen? Can anybody recall that for me? What were things we have already seen? What we have discussed yet? Abhishek, Dipanshu.
Sir,
Yeah. And what are things we have seen in previous class or till date in distribution system? What we have seen yesterday? What? Just recall the segment.
hello, yes, sir.
Yes, Abhishek.
Sir, we have done the AC distribution, sir, primary distribution system,
Okay.
and sir, secondary distribution system, DC distribution system, sir, that was going on, sir.
Okay. In distribution system, what are things we have seen?
Sir, in DC distribution, sir, two-wire DC system, sir, we have seen, and three-wire.
Okay. So what is the difference in the that two wire and three wire system? What advantage disadvantage we get? Anyone
Sir,
can
number
respond.
of conductors are less in means in two-wire system. Two conductors are used, and
Okay, in three wire system, an extra benefit what we get in three wire system.
sir, high voltage.
Okay, high voltage means we used to get uh, two set of voltages, right?
Yes, sir.
One would be L between one line and one neutral position, and another would be between the two line, right?
Yes, sir. Yes, sir. If the load requires high voltage, then it will like supply to them.
Yeah. Okay. So that is your two wire and three wire DC system. In methodology also we have seen something. Right? In methodology also we have seen two generator method. How from two generator we could means in three wire system I drew that particular segment, right? Yeah, how to we could draw out just a minute. This one, that is a two generator method. Okay, in this what I have showed you about two generating generators would be used. Okay, either take it as your three wire system. Okay, where one generator and another generator would be there, right? This would be collapsed and grounding would be there, and from this one line would be there, from this one line would be getting, and from this one line we'll getting, right? That is your three-wire system. Okay, in generator method. Okay, this generator used to get, right?
Yes, sir.
Now, so similarly we have other two also. Okay, we also go with your uh, what to say, balancer set. Okay, okay, one balancer we call, okay, yeah, this one. Okay, balancer set where we have seen your balance, okay, load and unbalance, means out of balance and a balance category. In that particular into three-wire system we have seen that particular figure. Okay, see over here, the three-wire system can be obtained from two-wire DC system by using a balancer set. So what we have seen is this three-wire system, how can it be affected when it is in a balance and out of balance. And now, and this category is different. Okay, this three-wire system could be drawn from your from this particular one, from two-wire system. Okay, like how it will be, your two-wire would be there, right? In two-wire, one generator set would be there from here. Let's in this format, and this would be I will draw in using this base. Just a minute. This would be your minus, and this would be your plus. Okay, this is a two-wire position. This is your single generator attached to it, right? This set. Now, over here, two balancers are being involved. Okay, how this balancer set is been created. Okay, if this is your balancer set. Okay, if two-wire system is there, what we do, we enhanced your two balancers in this particular. How to add two balancer? Will take, this is your one balancer. Okay, and it will be your over here. Okay, these are your balancers. These particular are the balancer. These are the two-wire system. Okay, initially it is your two-wire system. Okay, but if we have to draw a three wires for three-wire system, okay, so we'll use this particular balancer to convert that two-wire system into three-wire system. Okay, so over here will be written, okay, the three-wire system obtain the two main wire DC generator and supplies power to the whole system. The balancers consists of identical two shunt machines. Okay, two identical two shunt machine coupled mechanically with their armature and field winding joint. Okay, see in this. Okay, I missed your this part. I missed one small segment, that is this position what they have written. Okay, their armature and field windings would be joined. Okay, so there would be another set. Okay, this is a complete set of balancer where two DC shunt machines are being involved in this, which are mechanically coupled. Means these points are mechanically coupled, and this is the entire system. Okay, DC generator, what is the powering your two-wire system. Okay, so this is one of the methodological way where we could convert or we could supply your three wire. So these are the methodology to obtain. Okay, either we could have two generator sets, either we could have your three wire DC generator, the same methodology what we do in previous one. Now another is your balancer set. From in this we used to convert this two wire system into your three wire system. Okay, so this two wire would be initially driven by your single DC generator, okay, where we attach to this DC send machine, which is mechanically coupled. Okay, so this is how we convert your DC, sorry, three wire systems. Okay, so this was all about your the segment. Okay, we'll come into this particular point in this particular point later. Okay, overhead and versus underground system. We'll study more uh, in detail. Let's go into the AC part. Okay, that is your this segment, right? Into this system. That is your connection scheme of a distribution system that accounts readily in few of the segments. Okay, so now can you tell what two schemes we, as I earlier I had told only you, to which two system we scheme we use to distribute this energy? Two schemes. Tell me. One is over here only it has been given. Okay, that is your relay system, and another is your
Sir, sir, ring main circle, sir.
okay ring. That is your ring main distribution system. Another is also there that we found. Okay, we generally study right now. Okay, that is your interconnected system, distribution system, distribution system. Okay, so these are three that we are going to see. Okay, now tell me, what is your radial distribution system? Over here also it has been written, but okay, tell me, what is your this radial distribution system? How it has been connected, or how you could recall where it has been used, or something. Tell me what you know about distribution system.
It is like a tree with branches, sir.
It's like a tree with the branches. Okay, tree with the branches. Okay.
Supply source is one.
Pardon?
Supply source is one, sir.
Okay. Supply source is one. Okay. Example would be your tree with branches. Anyone else could define more of it? Okay, is okay. Fine. This is what you have told is also okay. Is perfectly defined as per now. So what is we'll see over here. Two things it has been highlighted itself over here. Okay, that is your in this system. Separate feeder radiate from a single substation to feed the distributor at one end only. Right, he's told only one supply system is there. So this is your substation, right? This is your substation, and if we have distributor from where we have to tap, so this will be only source and it will be connected from one end only. Okay, so if we draw this particular segment in a more elaborated way, okay, if we draw this in more elaborated way, it can be drawn in this particular segment, that this is your one distributor, this is your another distributor, and this is your substation. Okay, this is your substation that would be fed at only one end. Okay, okay? It may have multiple sources. Okay, now only one, or we could call as single path. Okay, one path. Okay, over here also, right? Single path, right? Single is part connected is connected to the distributor. So if we name as distributor A, and this is named as distributor B, okay, and this is your substation, okay, localized substation from where it will be distributor and it will, right? So only one path or single path is connected between a distributor and this substation, and this is called your radial distribution system. Okay, now in this what happens, these are the service mains. Let's draw more. These are the service mains which we have tapping from distributors, right? These are the service mains, multiple tappings that will be connected to the consumers. Okay, so these are the service. Now if fault occurs in either of the feeder, okay, either fault occurs in this or fault occurs in this. This is a feeder, fault occurs, okay. If fault occurs in either of the this, okay, in which area if fault would be occurring, like let's assume, okay, if in this particular segment fault occurs, so this entire area is being isolated. Okay, so what it says that fault occurs in either of the feeder, okay, the distributor, okay, the distributor, all the consumer connected through it is isolated. Okay, as if fault occur in this feeder goes out, so this entire distributor will not get, and if distributor is not getting, so no service means will be getting a supply. Okay, so entire will be affected. If fault occurs in this particular segment, this entire region would be isolated, would be affected, right? So, and we generally low in India, okay, more than 90% or 95%, more than 95% are, it is connected in the radial format itself. Okay, so that's why if any fault is there or any repairing is there in your locality, we assume the power goes out, right? We generally don't have that particular thing. Okay? So in India, you could assume that 99 or 90, more than 95% are being used in your radial system only. Okay, it has been connected in this system only, in radial system. Okay, Can you point out what will be the advantages and disadvantages? We have talked just now, but what will be the advantages if we talk about? Tell me, what will be the advantage and disadvantage of this radial system? Okay, only for this radial system. Okay, so as one of your friend told, right, it is like a tree. So if it is like a tree, then the basic concept will come, okay, that planning, okay, that it is simple in planning. Okay, we'll remove this. It is simple in planning.
Low cost, sir.
Okay, well, that initial cost, we call that initial cost. Okay,
Initial cost.
initial cost is low. Okay, initial cost is low or minimum. Okay, now if this is your planning is simple, okay, and planning is simple. So if planning is simple, the operation would be simple, designing would be simple. So it will be simple in planning, design. Okay, only yes, you have to lay down that this segment is your source until what the end it is been have to fed. So it will be feeding as a distributor, and how many house or consumers will be tapped, it will be tapped in this manner. Okay, this is very simple in that. Now in operation is also very easy, right? As you know, fault occurs in any of the particular segment, entire unit should be outrated, right? So the operations is also very easy. We don't have to think lot of worry. We don't have to worry. If anything happens, we'll and remove, isolate the entire segment. Okay, operation is also easy, right? Now another segment is, it is very useful. Okay, it is very useful, uh, or you could say when generation, okay, generation uh, is in low voltage. Okay, we consider that generation is in low voltage. These are the advantages. And another segment that I have already questioned you once is, it is very suitable, right? It is very suitable where the stations or the uh, substation is located at the center of the loop. Okay, it is suitable, okay, when stations, okay, generating stations or your substation is located at center of the load. Okay, so these things we have to remind for the advantage. That is very simple in design, in planning and operation. Initial cost is low, means lay down cost is low. Okay, generation is of low variable. It is useful. Okay, useful when generation is in low voltage. And another segment is, it is suitable when this stations, either your substation or your generating station, either choose any of that particular point, is center of the load. Okay, this were the few advantages that you have to keep in mind. It may come in more and other way. Okay, that makes very different in radial and this part, that is your center load part. I have asked you once that question, that particular question as well. Okay, now disadvantages. Okay, one is your definitely that fault one. Okay, if fault occurs, the entire segment is removed, isolated. Okay, that is very uh, particular thing. Okay, now another segment is, now if we are supplying this particular distributor, so what happens? Okay, the major disadvantage of this particular segment is, okay, this distributor. Okay, this particular point, if we will draw the old one. Okay, if we draw the old one, if this is your feeder, okay, and this is your distributor, and this is your distributor. Okay, in this particular segment, what happens? Okay, distributor near the feeder. Okay, the feeding end. Okay, near the feeding end, this is your feeding end. This particular point at this end is heavily loaded. Okay, sorry. This is heavily loaded. Okay, this particular point. Okay, this particular point. Okay, it is very heavily loaded. Okay, so this is a one disadvantages. Okay, distributor. Okay, distributor near the feeding end. Okay, this feeding end is heavily loaded. Okay, this is one. Now another segment is the consumer at the far end. Okay, this consumer at the far end from the feeder. Okay, this is a feeder. The consumer at the far end from the feeder would subject to frequent voltage fluctuations. Okay, there would be a frequent if it is at this end. Okay, this particular end, this they will assume your frequent voltage fluctuations. Okay, with the variation of load, if the loads would be varying, so this would be definitely happening, the fluctuations in the voltage would be happening. Okay, so these two are the major disadvantages you could consider of this uh, radial system. Okay, one is the near distributor near to the feeder is heavily loaded, and the consumer at the far end, okay, the far end would be facing your frequent voltage drops. Okay, in the variation of load, whenever the load will be high or low, there will be definitely will feel more or more voltage fluctuations. Okay, another is your ring mains. So what is ring main distribution system? Anyone could tell me what is rings main distribution system?
So different feeders are connected with different substations.
Anything else? So ring main distribution system. Okay, now in this, what happened, what he told is also okay, and this is what I'm telling is also okay, that your feeder, okay, this feeder is the responsible thing in it, okay, either in it is being drawn in this particular segment or in this particular segment, whatever be the design you draw, okay. In this, what happens, this and the feeder, okay, this feeder, okay, I will name this particular segment in this format. This is your substation. Let me draw. Okay, this is your substations, or somewhere you could also find in this particular format. Okay, this is your substation. Okay, and I will let you know how it works. Okay, this is your okay. Let's draw one more. And name them as from here A, B, C, D, E, F, likewise, right? These are the distributors. These are your service main. Okay, and this over here is your substation in it, right? Now, in this feeder, okay, this is your feeder. Okay, this is your feeder. This is your feeder. Okay, this particular point is the feeder. The feeder covers the whole area of the supply. Okay, in the ring fashion. This is in the ring manner. Okay, it covers in the ring fashion, and finally terminates at the substation. Okay, and then it comes where the substation where it is started. So if we call this is a starting point, it would be in a ring format and would be ending at this particular format. So this is forming a closed loop. Okay, so that's why it's also called as closed loop ring main system or closed loop distribution system as well. Okay, so this is forming a closed loop and it looks like that. So that the names have been derived from this particular facet. Okay, now in this, what happens if fault occurs in any point of the segment? Okay, if fault occurs in this particular unit, so only this would be terminated. Okay, or if fault occurs in this unit, only this particular would be isolated. Okay, or it will be affected. If fault occurs in this particular part, only this particular would be affected. Now it's saving. Okay, if fault occurs in one segment, they do not require to segregate these other remaining portions or another loads. Okay, so that is what the benefit we got. Okay, so generally and from here if we see in more detailed format, okay, we have given this ring format because it started from this end and this end. Okay, if we go in detail in this particular segment, if we name this 1 2 3 4, and from here they would be taking out, okay, uh, taking out your distributing part. From each, I'm taking out few. Okay, and from each, okay, and over at this end, it is your substation, right? This is your point S. This is your 1, 2, 3, 4, and we'll give as name as your A, B, and C, right? Now, this is your distributor part. Okay, if this fault occurs, this will be isolated. Now, in this fashion, if we see, okay, if fault has occurred at this particular end, okay, at this particular end itself, right? This is your point. So what will be there? The power is not cut off for these two reasons, right? Power is being supplied, right? Power is being supplied to this areas. From this, the power will be supplied. Okay, if fault occurs somewhere over here, okay, the fault would be supplying, okay, to this unit. Okay, if fault occurs in this particular point, the power would be supplied from this particular end. Okay, that's why it is constructed in this manner that the power package or the reliability of power would not hamper. It will be definitely would be there in entire scenario. Okay, in whatever scenario it occurs. Okay, until unless there is a major workout or anything. Okay, it may be considered. Okay, so it consists of two or more paths, okay, as in previous radial it was only one path, okay, but in